About 70% of our planet is covered in water, and the vast majority of that water is in the salty oceans. But in a paper published recently, scientists from Germany propose that the Arctic Ocean was, at a relatively recent few points in Earth's history, actually entirely freshwater. Rivers and meltwater flushed out the salt, and lower sea levels worldwide at the time meant it couldn't come back, at least for a while. Getting to grips with how and exactly when this was happening is critical to our understanding of how climate change affects the Arctic. I'm Katie Haler, and I heard more from Walter Geibert.
We found that the Arctic Ocean was in peak cold periods not only covered by a very thick ice shelf, but it was filled entirely with fresh water below these ice shelves. The Arctic Ocean is much larger than the Mediterranean Sea, 2 or 3 times the volume roughly. In addition, we're also talking about a southern extension of that. That's the Nordic seas. And these two forms an enormous basin, always covered to some extent with ice these days, but in cold periods it was with much heavier ice cover.
If the Arctic Ocean is seawater currently, what evidence do you have that it was once freshwater?
We looked at marine sediments, and usually sea salt contains trace amount of uranium. That's rather constant. And that creates a trace of thorium, and that's raining from seawater all the time to the seafloor. And that's radioactive. And in the Arctic Ocean, we found that this trace that is anywhere else at the seafloor, otherwise, is missing in the Arctic Ocean over large regions.
What time periods are you talking about?
To very specific time intervals where we see this depletion. And dating Arctic sediments has really been challenging for decades now. We are a bit careful with narrowing it down, but we try our best and say there was one interval that was about 70,000 to 60,000 years before now. And there's another interval that ended 131,000 years ago and started, well, we don't know, 10, 20,000 years before.
Do you know very much about the climate of the Arctic in those time periods?
We've got quite a lot of information from Greenland ice cores, and they show a really interesting thing. There are some sudden jumps where it gets warmer by several degrees, and they're really sudden, and then there's a slow cooling after that. And for some of them, explanations have been found or proposed, but some of them remain a mystery. It remains a mystery why they occur in more or less regular intervals. Maybe we can add a possible explanation here and also solve a few mismatches.
I'm trying to picture what's going on because if the whole of the Arctic Ocean is fresh water and you've got this enormous ice shelf on the top, what's to stop it mixing with salty water from the sides?
Well, we had the lower sea level at the time. A lot of ice was bound on land. That lowered sea level, and the connection to the Pacific is really shallow. So you cut that off once you lower the sea level by a few tens of meters. And then you only have an outlet to the Atlantic. You close several outlets there, and then you're only left with very few places where the fresh water can leave. But the fresh water keeps coming in from a huge region by glaciers, by some rivers that were still there, and it keeps going in and it can only leave in a few places. And these restricted gates to the Arctic Ocean, we believe that they were just too small to enable a mixing of the entire Arctic Ocean with salt water.
How did things change then? You've got this kind of cycling taking place.
Yeah, so far we can only clearly show two cycles. The end of these cycles, I would imagine that to be quite a sudden event, because once you start flooding this basin with seawater, it will fill up from below and push out all the fresh water above. And that could happen, well, I don't know how long it would take for an entire ocean, no one knows, but it would be a time scale of years to decades maybe. Once this happens, the central Arctic would get much warmer because the ice shield would be thawing from below. That would take a while then to freeze again and to fill up again with fresh water, if it would do that.
If this stands up to scrutiny, what can we learn from, as you say, quite sudden changes in the conditions of the Arctic?
Now we have a better understanding of when the warm periods in the Arctic were. It's a bit ironic that we need to have these cold periods dated really well so we can then specify what were the warm periods between.
How confident can you be in your findings when you're trying to date sediments that are spectacularly old?
To be honest, that's going to be controversial. What we've done now is really we could correlate for the first time sediments all across the Arctic that look very, very similar in the patterns. And then really getting the absolute chronology better is then much easier once you know what you're comparing to what.
That was Walter Geibert from the Alfred Wegener Institute for Polar and Marine Research, and the paper he was talking about has just been published in the journal Nature.